Section 6.1 is solving systems by graphing. I can solve system of equations by graphing, and I can analyze special systems. Big ideas here. Systems of linear equations can be used to model problems. Systems of equations can be solved in more than one way, and one method is to graph each equation and find the intersection point, if one exists. Two or more linear equations form a system of linear equations, and any ordered pair that makes all of the equations in the system true is called the solution of the system of linear equations. Example 1 here is solving systems by graphing. So to find the solution of this system, we are going to graph each line and find where they meet. So we're going to graph this line in yellow. I'll do this one in white. Okay, so with our first line, we're going to graph these just like we did last chapter. So my slope is 1, and my y-intercept is 2. I'm going to start at 2. I'm going to use my slope of 1 to go up 1 over 1, up 1 over 1. Remember, we can write whole numbers as fractions. Okay, and I'll connect those dots here in just a second. For my second line, my slope is 3, which remember we can do as 3 over 1, and my y-intercept is at -2. So I'm going to go to -2. And instead of going up 1 over 1, I'm going to go up 3 over 1. Up 3 over 1. And just by doing the points, I can see where both of these are going to meet. But I will draw in those lines there for us. Connect the dots. Okay. And my yellow line there. Got a little bit off there, but we can see the idea there. Arrows on our lines. And again, we want to make sure our lines are long enough to at least get through where they meet. Okay, this point right here, where they meet, that is our solution. If we plug in the point 2, 4, okay, 2, 4 into both of our equations, it would make them true. Let's check it. Y equals 2 plus 2, 4 equals 4. 4 equals 3 times 2 minus 2. 6 minus 2 is 4. So it works for both of them. This is the only point that will work for both. So the solution of this system is the point or the ordered pair that makes all of the equations true. Go ahead and pause and give this one a try if you'd like. Okay, I have two lines, so I'm going to graph them both and find the intersection. With my first line, my slope, if there isn't a number there, remember it's 1. So I'm going to go up 1 over 1. My y-intercept is at 2 again. So 2 up 1 over 1. And I can go ahead and draw in that line right away if I want. We want to extend it all the way through our graph so we can see where it intersects our second line, since we don't have those points yet and aren't sure where that's going to go. My second line here, my slope is 2. It's the number in front of my x. And again, that's 2 over 1. My y-intercept is my last number. Remember, our y-intercept, 4, tells us where we begin, and our slope tells us how we move. So here I'm going to start at 4, I'm going to go up 2 over 1. I can also go down 2 back 1. So when I connect my dots here, I find the point of intersection is behind our intercepts, but that's fine. It's wherever they both meet, which here is that point. Where both lines hit that point, they intersect there. It's our solution. So our solution here is -2, 0. Remember, ordered pairs are always x and then y. Writing a system of equations here, scientists have studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown on page 365. After how many months did the alligators weigh the same amount? So on the picture on page 365, they give us some information. For alligator 1, they tell us that initially when it's born, it was 4 pounds, and that every month it increases by 1.5 pounds. That information, guys, the 4 pounds at birth, that's our B value. That's where we begin. That's our y-intercept. And our 1.5 pound increase per month is our slope. And I can write 1.5 pounds as 3 over 2. For alligator 2, it tells us that when it was born, it was 6 pounds. Remember, that's our y-intercept, our B value, where we begin. And every month it increases 1 pound. And that is our slope. And again, we write slope, if it's a whole number, as over 1. So alligator 1, we're going to start at 4. And I'm going to go up 3 over 2. Up 3 over 2. And then this is months. And this is weight. For alligator 2, I'm going to start at 6. And I'm going to go up 1 over 1. When I connect my dots here, okay, I'm only going to go from the y-axis. Okay, I can connect those dots because it didn't just go from being 0 months to 1 month. It went every day in between there. So I can connect those. I can also put an arrow on one end, but only on one end. We can't have negative months. Okay, it was born at 0 months. Same thing for my second line. I'm going to start at 0 months and draw my line through. I can put an arrow on the end of that as well. And it looks like where these intersect is right here. So, after how many months did the alligator weigh the same? The alligators weighed the same after 1, 2, 3, 4 months. Now, if they asked how much did the alligators weigh, that would have been our y value because weight is our y value. So we'd have said 10 pounds. Go ahead and pause and try this if you'd like. One satellite radio station charges $10 per month plus an activation fee of $20. So the first one charges $10 per month. Since it's per month, per something, that's our rate of change. And remember, we call that our slope. So we're going to go up 10 over 1. And the $20 activation fee, that's our where we begin, our B value. or our y-intercept. Okay. The second service charges $11 per month. Remember that per month tells us it's a rate, or our slope. So 11 over 1. And an activation fee of $15. So it's going to start at $15. When we go to graph this, I don't really want to have to count up to 20 and then count up 10 and over 1. I don't have to want to count to 15 and then up 11. So I'm going to use a scale here, and that way we can get more information on our graph. So our months, because it's $10 per month, that means that our time is months, and that's what we're going to use for a scale on the bottom. I can just go by 1 there. Also, it asks after how many months is the cost the same. In what month was the cost the same? So we're looking for months. On the side, I'm dealing with cost. And here, I'm going to go by tens. I have 10, 20, 11, and 15. So I'm going to go by tens. I can fit up to 120 here. I did just put the first quadrant because we are dealing with costs and subscriptions and things that start at 0. We can't have negative months of subscription. So I'm going to label my axis here, 38. Okay, for my first one, I'm going to have to use a different color here so it shows up. I start at 20, and I increase 10 per month, so up 10 over 1. From 30, up 10 is 40 over 1. Up 10 to 50 over 1. So I can draw in my line. Here. And I can put an arrow on the end of that. For my second, I'm going to switch it here as well just so it shows up a little better. I start at 15, so right in the middle, and I go up 11 over 1. So here we have to be careful. We have to actually do that math. So if I'm at 15 and I go up 11, I go to 26, somewhere over here, over 1. 26 plus 11, 37 over 1. 48 over 1. 59 over 1. 70 over 1. And there it looks like I have a match. So if I connect my dots here, and you can do these with a table as well if you'd prefer. Let me do that in red. For some of these where you have to kind of guess values, tables work too. And an arrow there. So where these intersect is right here at $70 and 5 months. So after 5 months is our answer. I'm going to go ahead and stop the first video here, and I will continue section 6.1 in another video.